Alright, on this video, I'm just going to do number 4 and number 5. And you're going to see, 4 is a good one to look at because both sides look equally as complicated. So we're actually going to work with both sides. You don't always just have to work with one side. And both for 4 and 5, the only thing that's really going to work is to put everything into terms of sine and cosine. There's nothing you can do. You can't factor anything out. There's no Pythagorean identities, and there's no fractions. So let's work with the left side. The tangent of x, I can change this to sine of x over cosine of x. Cotangents, just the reciprocal of that, is cosine of x over sine of x. So let's just simplify the left side, and then you'll see we probably have to manipulate the right side to get both sides to equal each other. Alright, so now it's kind of like the last one where you added fractions. You got to find an LCD. The least common denominator is just going to be the product of cosine of x times the sine of x. So this first fraction, I'm going to have to multiply top and bottom by sine of x. So I get that common denominator of sine times cosine. So when I multiply these, I get sine squared of x. And you'll start to see the pattern. So if you're going to have a sine squared, you're probably going to get a cosine squared. So the second fraction, I'm going to multiply by cosine of x, top and bottom. So this is the common denominator, so that's good. And then cosine times cosine is that cosine squared of x. So there it is. So sine squared plus cosine squared, that's just 1 up top. And it's 1 over cosine of x times the sine of x. Alright, and I guess there's a couple ways you could do it. Alright, so I could look at the right side. I could say, alright, this secant is the same as 1 over cosine of x. This cosecant is the same as 1 over sine of x. And then I can just prove that both of these are equal. So that's number 4. And then I just want to do one more, number 5. Alright, number 5. Okay, this one we're going to work with the right side. This obviously looks a lot more difficult. And nothing cancels out. You don't have any of the same trig function. There's no Pythagorean identities. You're not adding or subtracting fractions. So same thing. You want this to equal the left side tangent of b. I'm going to actually show you 2 ways of doing it. Now, probably the more conventional way is just taking this cotangent and writing as cosine squared over sine squared. So that's what we're going to do. And I'll put this over here. So it's still going to be cosine of b over sine of b. And then this cotangent squared changes to cosine squared of b over sine squared of b. And then when I just look at the denominator, this sign is going to cancel out with one of these signs right here, so I get rid of the squared, and it's just sine of b. So this is what you have. You have cosine of b in the top divided by, what is that, cosine squared of b over sine of b. And then if I change flip, I keep that cosine of b in the top the same. I multiply by the reciprocal of this bottom, which is sine of b over cosine squared of b. And then the cosines cross cancel. This cosine cancels out with one of these. So then you have sine over cosine, which just equals tangent. Now that's the way we've been doing most of these. Here's another way to look at it. There's always other ways to look at it. If I looked at this right here, this whole thing, well actually let's just focus on this. Cosine over sine, that's cotangent. So I'll put or, this is another way of doing it. I could say that's cotangent of b, that's in the top, and I just put it over cotangent squared of b. And cotangent over cotangent squared is 1 over cotangent, which is the same as tangent of b. So that was kind of a thinking outside the box way of doing it, which actually was a lot quicker. So what that proves is there's many ways to do this. Whichever way you get to work and however you think, it's going to equal the other side, then just go with it.